Hi, everyone. My name is Eve Vaviakis. I am a postdoc at Cornell University, and I'll be presenting today on behalf of my co-authors, who are all from the Deep Skies collaboration, on DeepSZSim, a new framework for fast simulations of the thermal Sunyaev-Zel'dovich effect associated with galaxy clusters for machine learning methods such as simulation-based inference. We're about to enter a new regime in which systematic uncertainties are going to be limiting our upcoming measurements. For example, for cluster cosmological constraints, we are limited by our uncertainties in those cluster masses. In the lower left-hand plot, you see scatter plots of SE galaxy cluster catalogs from current experiments like SBT and ACT, as well as forecasts for upcoming experiments like the Simons Observatory and CCAT, as shown in the blue points, which we'll be seeing in the next few years. This catalog is going to push to lower masses and higher redshifts than we were able to achieve before. But one of the benefits to simulated cluster catalogs is our ability to arbitrarily tune these parameters to different masses and redshifts, as well as to tune the input physics that govern these galaxy cluster halos to try to improve our cluster mass inference through machine learning. DeepSZSim was developed in order to enable fast and flexible simulations for large SE cluster training sets. We have current simulations like hydrodynamical simulations, which are detailed and robust, but are computationally intensive, and DeepSZSim is designed to be much more fast than these types of simulations. You can see one of our simulated submaps here, where the thermal SE effect is produced based on thermal pressure profiles from Battaglia et al. 2012 fits, which you can see on the right-hand side for various mass ranges. And our idea is to use these CRIC simulations in combination with other upcoming simulations of optical and X-ray clusters for simulation-based inference for cluster mass. Here you can see a flowchart of DeepSZSim, which was designed to be very user-friendly and highly customizable. Based on an input mass and redshift distribution, such as our generated flat distribution, you can combine a cosmology and input values for different observational parameters like beam size, pixel size, and noise level to produce, based on the Battaglia 2012 fits, a Compton Y profile, and therefore a Compton Y submap and SZ signal submap. You can combine this with simulated CMB signal from CAM, as well as a simulated noise map, resulting in the final submap. DeepSZSim is just one part of a larger nexus of fast simulations. We also have strong lensing and astronomical observation scheduling simulations. And soon we'll also have a CMB simulation and optical and X-ray cluster sims. Thanks so much.